For your notes today, you might want to have a periodic table nearby. I'm going to be giving you one in class soon if I haven't done so already. And if you can't find that one or haven't had a chance to give it to you in class just yet, you can always find a copy of the periodic table in Schoology. So today we're going to be refreshing your memories on how to look when you look at an atomic symbol, what all the numbers mean. So if I gave you this symbol, 8, 3, Li plus, the 8, that top number there, is what we call the mass number of our element. And that's where we're going to take the number of protons the element has and add it to the number of neutrons that it has. That's that guy. The number 3, that guy is what we call the atomic number. That is the number of protons only. Now, if you look at a periodic table and you find the symbol for lithium, so I've got a periodic table handy here. Here's lithium. And so you'll see 3 Li 6.94. If you're wondering, where's the 6.94? We don't put that number on our atomic symbol because that is something called a weighted average that you're going to see a little bit more about later on in these notes. There are things called isotopes where there are different types of lithium. All lithium atoms have 3 protons. That's what makes lithium lithium, are the 3 protons. Your neutron number could vary though. So you could have a heavier isotope of lithium. You could have a lighter isotope of lithium. The difference between the heavier and the lighter isotopes are how many neutrons it has. And then we average all those different isotopes together, and that's where the 6.94 comes from. The atomic number never changes, and that's why that one can go on the periodic table. Now, sometimes when you're looking at an atomic symbol, you'll see a charge next to the symbol, either plus, minus. Sometimes it has a number, sometimes it does not have a number. If it doesn't have a number, it's an implied 1. You can write those charges either +1 or 1 plus. You could say +2 or 2 plus. You could say -3 or 3 minus. There is technically a difference, but the College Board doesn't care. And therefore, neither do I. So it asks us to fill out this chart using a periodic table. Well, the atomic number always, always, always tells you your number of protons. Those 2 columns are going to be equal. Your neutron number, you cannot figure out what the neutron number is just by looking at the periodic table, because the periodic table is an average of the isotopes, and the isotopes' neutron number varies. So I would either have to tell you the neutron number or I would have to tell you the mass number. And you could use one to find the other. So that's protons plus neutrons. And then charge, you're going to compare the positive protons to the negative electrons and see what there is more of. So this guy, when we look at our symbol 31H, the 1 is the atomic number. All hydrogen atoms have 1 proton. That's what makes hydrogen hydrogen. Now the 3 is the mass number, protons plus neutrons added together. Therefore, this particular isotope of hydrogen happens to have 2 neutrons. Now, if the charge is 0, if it's neutral, that means that we have to have the same number of positive protons as we do negative electrons. So this particular one is a neutral atom of hydrogen. This next guy, the 2512 Mg plus 2, The 12 is the atomic number for magnesium. You can find it on your periodic tables. Sometimes people get a little confused and they say, oh, it's +2, so does that mean it has 14 protons? Nope, all atoms, all particles of magnesium have 12 protons. That's what makes magnesium magnesium. Now this particular one has a mass of 25, which means we must have 13 neutrons to do 12 plus 13 equals 25. This isn't a neutral atom of magnesium, though. It has a charge of +2. There are more positive protons than there are negative electrons because it's positive 2. So the way I kind of like to think of it, the proton team is playing the electron team in basketball. The proton team is winning by 2 points, +2. If the proton team has 12 points, that means that the electron team must only have 10 points. This last example that I'm going to do with you here, if it has 17 protons, we know it has an atomic number of 17. It tells us this one has 18 neutrons, so we could add 17 and 18 together to get the mass number. So now we know the mass number is 35, the atomic number is 17. You could go to a periodic table and you say, which one's number 17? Oh, it's chlorine. Okay, now that I know it's chlorine, I'll plug that part in, Cl. And now when we compare our positive protons to our negative electrons, we have more negative electrons than positive protons. So now our negative ones are winning. The electron team is winning. So the charge is -1. Don't forget to put your charge over here on your element symbol. So you can either write -1, you could just write minus, 1 minus, all those would be acceptable.